So in the simple cubic unit cell, there is a presence of 8 lattice points which are arranged at 8 corners of the unit cell. Only 8 particles. There is no body-centered particle here. So in case of body-centered cubic unit cell, there is a presence of 9 lattice points in which 8 particles are at the corners and one of the particles is present at the center of the unit cell. Okay. Next, the example for body-centered cubic unit cell is nothing but example is CSC. CSCL. And we will go for next the face-centered cubic unit cell. So in this face-centered cubic unit cell, there is a presence of 14 lattice points. Among 14 lattice points, 8 at the corners and 6 at face center. Face center. So 8 particles present at the corners and 6 particles at the face center. So along with the corner particles, there is a presence of 6 more particles at the center of each face. Okay. So let us mention or represent the number of particles present in the face-centered cubic unit cell. So first we will represent one of the cube like this. This is one of the cube. Okay. So in this cube there is a presence of 8 corners. So we will represent the 8 particles at 8 corners like this. 8 particles at 8 corners. So along with these 8 particles at the 8 corners, there is a presence of 6 more particles at the center of each face. So this is one of the face. So for this face, the center is the here, and at this point exactly there is a presence of one of the particle. And again the second face is nothing but at this. So in this face also there is a presence of the particle. And this is one more face. In this face also at the center there is a presence of one of the particle. So here also there is one more face, fourth face. At the center of that face also there is a presence of one of the particle. And this is one of the face. Front and back, there will be two more faces. So in the front face at the center there is a presence of one of the particle. So this is the back face. At the center of the back face also there is a presence of one particle. So totally not only at the corners presence of 8 particles, there is a presence of 6 more particles at the center of each face. Okay, so that is the the face-centered cubic unit cell. There were 3 different types of unit cells in the cubic system: simple cubic unit cell, body-centered cubic unit cell, and face-centered cubic unit cell. So the example for this face-centered cubic unit cell is NBC. NBC. Okay, so now, so we will study how to calculate the number of particles exist per unit cell in case of simple cubic, BCC and also FCC. So we know that simple cubic unit cell containing 8 lattice points in which all the 8 lattice points are arranged at 8 corners of a unit cell. Next, coming to the BCC, there is a presence of 9 lattice points in which 8 lattice points are arranged at 8 corners and one of the particle exists at the center. In case of face-centered cubic unit cell, there is a presence of 14 lattice points. Among 14 lattice points, there is a presence of 8 lattice points at the corners and 6 lattice points at the center of each face. Now, we will calculate the number of particles exist per unit cell in all the 3 cases. Okay, so number of particles exist per unit cell can be calculated by using the formula. So before going to go for the formula, we will go through one of the corner particles. So this is one of the cube or unit cell. So in this unit cell, there is a presence of corner particle. So this corner particle is linked with how many unit cells in the crystal lattice. So in this crystal lattice, there is a presence of many number of unit cells. So if we consider one of the particle, this square as a unit cell, so this unit cell is linked with 4 more particles directly at the center. Okay, so this center is linked by 4 more particles, so 4 different particles. So only at the each phase. So if we place one more cube like this, one more unit cell like this, so this unit cell also containing the particles. So if we keep this corner at this corner like this, there is a presence of 8 unit cells which is directly linked with the central particle. That means each corner particle is directly linked with the other 8 unit cells. Okay, so a particle present at the corner of a unit cell is directly linked with 8 more unit cells. So what is the share of this particle exists per unit cell? It is found to be 1 is divided by 8 unit cells. The share is found to be 1 by 8. So 1 by 8 is nothing but the share of each particle present at a corner exists per unit cell. So how many such kind of the corner particles are there? So 8 corner particles are there, and each and every particle is shared by 1 by 8 to each unit cell. Hence, we can say number of particles exist per unit cell can be taken as number of particles present at corners into share of each particle. Share of each particle. That means in case of simple cubic there is a presence of 8 lattice points. So we will consider one of the lattice point exists at the corner. So this corner particle is directly linked with 8 more unit cells. So the share of that corner particle exists per unit cell is found to be 1 by 8 is the share. And how many such kind of corner particles are there totally? 8 corner particles. So totally from each corner particle share is 8. 8 more particles are there. Totally how many particles exist per unit cell in case of simple cubic is found to be calculated by using the formula. Number of particles exist per unit cell is equal to number of particles exist at the corners into share of each particle exist at the corner. So in case of simple cubic SCC, so simple cubic crystal unit cell. So number of particles at the corners is 8 and share of each particle is going to be 1 by 8. So that 8 gets cancels with one another. So that one particle exists per unit cell. So this is in case of simple cubic. So in case of simple cubic unit cell, there is a presence of only one particle exists per unit cell. This is very, very important for the examination. Next, coming to the body-centered cubic unit cell. In this, 9 lattice points are there. So among 9 lattice points, 8 particles at the corners and 1 particle at the body center. So if you want to calculate the number of particles exist per unit cell in case of BCC, so we have to go for the number of particles. So we will calculate the number of particles exist per unit cell in case of BCC. Okay, so for that we need to take the equation number of particles exist per unit cell in case of BCC is equal to number of corner particles into share of each particle, that is common in both the simple cubic and also BCC. Along with this, there is a presence of one of the particle at the center. So number of body center particle into share of body center particle, BCC particle. Okay, so in this case we know that the corner particle is having a share of 1 by 8. So 1 by 8 8 number of particles are there. One particle and also shape is 1 by 8, that is common in BCC also. So in case of the body centered, so body centered particle is not linked with the other unit cells. So that means this particle belongs to only one unit cell. So number of body centered particle is 1 and corner shade is not linked with the other unit cells. So shade is 1. So that 1 by 8 is 8, 1 plus 1 8 1 is 1, only 2 particles exist per unit cell. So this is in case of BCC. So we have calculated the number of particles exist per unit cell in case of BCC. So body centered is also known as BCC. Phase center is also known as FCC. So simple cubic is going to be SCC. Okay. So next we will go for the calculation of number of particles exist per unit cell in case of phase center. So in this phase center there is a presence of corner particles. Along with that there is a presence of phase center particle also. Okay. So we will calculate the number of particles exist per unit cell in case of FCC. So the formula is found to be changed. So this is up to this it is common. Along with that there is a presence of phase center particles. So number of phase center particles, FCC particles, along with that shade of phase center particle. Shade of phase center particle. So you observe the corner particles are found to be 8. Its shade is 1 by 8. It is common. It is similar to simple cubic and also BCC. And in case of FCC, along with this 8 corner particle, there is a presence of phase centered 6 particles also. So we will take one of the phase. So there is a presence of the particle present at the center of each phase. So this is one of the phase. In this phase, there is a presence of one of the center particle. A particle present at the center of that phase. So if we take one more phase like this. So if this unit cell is linked with the other unit cell like this, so that phase centered particle is directly attached with one phase and one unit cell and also another unit cell. That means the particle present at the center of each phase is directly linked with the two unit cells. So like this. So if there is one of the particle at the phase center in this case, so this if it is one of the unit cell and if it is another unit cell, so these two are linked with one another by this phase particle. That means the phase centered particle is directly linked with the two particles. So two unit cells. Okay, next we will calculate the number of particles exist per unit cell in case of the phase center, that is 1 by 8 into 8 plus number of phase centered particles are totally 6 into share is, since it is linked by 2 unit cells, so each phase centered particle, the share is 1 by 2. So 1 by 2 is the share of each particle exists at the phase center and number of such kind of phase centered particles are 6. So totally we will calculate 1 by 8 into 8 is going to be 1 plus 6 into 1 by 2 is going to be 3. Totally 4 particles exist per unit cell. So this is nothing but the calculation of number of particles exist per unit cell in case of simple cubic, BCC and also FCC. Okay. Once again let us study. So in case of simple cubic there is a presence of 8 lattice points in which all the particles are lattice points are arranged at 8 corners of a unit cell. So each particle exists at the corner is linked by 8 unit cells. So that the share of this corner particle is going to be 1 by 8 per unit cell. So how many such kind of particles are there? 8 particles. So the number of particles exist per unit cell in case of simple cubic unit cell is found to be 1 by 8 into 8, which is found to be 1 particle exists per unit cell. So in case of BCC, there were 9 lattice points in which 8 particles at the corners and 1 of the particle at the center of the body. So at the phase center, there is a presence of At the corners, there is a presence of 8 particles and the share is 1 by 8 from the each corner particle. Along with that, there is a presence of one body-centered particle, 1 into 1. It is not linked with the other unit cells, so share is only 1. So that we will take the sum of these two. That is 1 by 8 into 8 is going to be 1 plus 1 into 1 is going to be 2, which is equal to 2 particles exist per unit cell in case of DCs. And in case of FCC, there is a presence of 14 lattice points, 8 particles at the corners and 6 particles at the face center. So corner particles share is 1 by 8 and such kind of particles are 8. Along with that, there is a presence of face-centered particles. The 6 number of face-centered particles are there. Along with that, share is going to be 1 by 2. So the calculation of this is going to be 1 plus 3 is going to be 4 particles per unit cell. So this is nothing but the calculation of number of particles exist per unit cell. It is very important. For each and every examination, you are going to get 2 marks question based on this. Okay. So based on today's topic, I am going to give you some of the questions. The first question is, what are ionic crystalline solids, covalent crystalline solid, metallic crystalline solid and also molecular crystalline solid? So we have to write the definition of all the different types of crystalline solids along with the examples. Okay. So second question is, what is space lattice? Then what is lattice point? And then what is unit cell? And also what is coordination number? Okay. So you should write the definition of all these 4 different types of concepts. And then we will go for the third question. And calculation of number of particles exists per unit cell in case of sigma cubic, BCC and also FCC type of unit cells. Okay, so we all know the answer for these questions and you write the answer in the book and post the answers to my WhatsApp. Okay.